Hi, Emily.
Hey, Mike.
How is it going?
It's going all right. How's it going for you?
Yeah, not too bad. Let me introduce us. This is Turingsaurus Lex, a podcast on law and AI presented by Marveri. My name is Mike Dockery. I'm a former corporate M&A partner at Morrison Foerster. I'm currently the director of product at Marveri. You are Emily Mu. You are a former PhD candidate in machine learning and AI at MIT, and you are now the founder and chief technology officer at Marveri. So today, I'd like to sort of just take stock of sort of where AI is, where it may be going, that sort of thing. But as a way of sort of getting into that conversation, I would love to just briefly talk about the Turing test. And I really don't know how seriously like actual AI people take this. Um, but it's always been sort of in the air around AI, especially for me. Um, so just to introduce it very quickly. So Alan Turing, um, so a giant in the world of computer science generally, one of the founders of AI as a field. Perhaps his best accomplishment is being the namesake for the Turingsaurus Lex podcast. But he also did a lot of other amazing things in his life. Um, but for these purposes, uh, he's very well known for having come up with this test of machine intelligence that's now known as the Turing test. The basic idea being that if a machine can talk to a human being and the human being can't sort of sort out that they are talking to a machine, in other words, if the machine can fool the human into think they're talking to another human, then you can say that machine is intelligent. At least that was the idea behind the Turing test. There's been criticisms over the years. It's gone through various incarnations. I think um, even the test as it is most recently thought of is not really the one that Turing proposed in his original paper. All that aside, this basic idea that if a machine can convince you that it is human, um, then it can said to be intelligent. That's the idea of the Turing test. So, um, I guess first of all, let me just ask that question. Like, for real AI researchers, where does this fall? Like, what's the thinking on the Turing test?
To be frank, I think in a research capacity, it's less probably considered than kind of in general pop culture. I know, kind of similar to the Turing test, a lot of people have been talking about AGI these days, which stands for Artificial General Intelligence. Um, and I think the two are sort of correlated in that everyone kind of, and especially a lot of reporters and journalists, want to know, like, have we hit AGI? Are computers effectively and machines able to perform tasks that have been traditionally done by human labor? And so I think from a research capacity, to be frank, I haven't heard too many discussions about the Turing test, but definitely both historically and recently, I know there's been a lot of consideration, kind of, especially in media, about the Turing test and about whether or not AI is sentient. And I think those articles go back even until even since like GPT-3 have been super popular, where um, I, there was a Google researcher slash employee who was working. This is a very famous media story. Who was working on one of the first iterations of one of the early language models, and believed that it was sentient, whatever he defined that to be, when he was talking to the chatbot, and ended up sort of leaving and raising an alarm and all of this sort of stuff.
Yeah,
So yeah.
yeah. So I mean, that sort of gets to the reason. First, I kind of suspected that that may be the case. That maybe this is more impactful in sort of pop culture than it is in actual AI research. Um, but everything you just said sort of gets me to one reason I want to talk about this is because, like, I think a lot of people kind of have the sense that, like, if the Turing test is a real thing, it's already been passed. I mean, even as you say, even earlier, way earlier models, it doesn't seem like it would be too hard for them to convince you that they were human if you didn't know you were talking to AI. There have actually been some research papers recently that also suggest that the Turing test has been passed. There was a paper out of UC San Diego which like directly asked this question: can AI models pass the Turing test? They found that recent models, if you sort of tune them in a way that you can disguise sort of, all the things, all the markers of modern AI, like over helpfulness and things like that. If you sort of aim them at passing the Turing test, they easily pass it. In fact, I want to say the paper, the AI did better at the Turing test in that research than the humans did. So the AI was able to convince more humans that it was human than the actual humans being tested. There was also this controversial paper that came out recently that did sort of unannounced research on Reddit in the Change My View subreddit. This one was actually even more interesting to me from a Turing test perspective because it wasn't like trying to pass the Turing test. It was just trying to convince people to change their views. Obviously, we don't have to go into all the controversy around that particular research, but one thing that they noted in the paper where they talked about their outcomes is that no one ever questioned that they were talking that any of the posts that they made were posted by AI. So again, even more interesting, right? Because like they're not actually trying to pass the Turing test; they just sort of passed it on accident. But there is this phenomenon, right, where like we it seems like we passed the Turing test and no one cares. And I gather that in AI research is because no one no one cares about the Turing test generally. But it does feel like there's this sort of phenomenon of like moving the goalposts, like wherever AI gets to, like whatever sort of tests we set up, or whatever you want to call it, AGI, general intelligence, um, sentience. I don't know how you could ever measure that, but like whatever tests we set up, it kind of feels like there's this trend towards like moving the goalposts on that. So like this can't be intelligence because this is AI and AI is not intelligence, right? So what are your thoughts on that?
Yeah. So to be completely fair, I think I don't doubt that AI and talking with the chatbot could definitely convince you that it's a human. Their responses are very human-like. But I think that almost matters less than sort of the ultimate question of how is AI going to change industry, right? And the core of that question is it is sort of more aligned with the definition of AGI, but again, I think that's also a buzzword where it effectively means, can AI replace sort of this almost white collar human labor and very like technical human labor, things such as software engineering, robotics, things like that. And I think while I know we had this conversation in the last podcast, while I don't think that AI can replace software engineers at the level that they are at now, I know there's some companies that are working on. Devin was a huge, what was sort of like trying to become the first AI software engineer, doing full engineering work and completing projects. But even kind of working with coding tools today and working with sort of it's clear that a lot of industries are going to shift because AI is able to, even if not replace, significantly impact those industries and the efficiency of those industries. And I think that both engineering and AI and law are sort of two of those industries. And so almost it matters less whether or not we ask the question of, is it sentient? Can it pass the Turing test? And I think sort of the more deep question is, given sort of the progress and the advancements, even if AI stopped today, right, in terms of sort of the core LLMs, these industries and how these industries are shaped and how people think about performing labor in these industries are going to be changed by AI. And so, how does that affect how we work and how we practice and how we interact? And I think that is sort of almost the deeper question than like, can AI convince you that it's another human being, if that makes sense. So I'm very interested in sort of those forms of questions, and I think that those are the questions that are sort of like people are really trying to grapple with across many industries these days.
Yeah, I mean, I certainly agree that those are more impactful questions, with maybe one exception. And I don't necessarily want to drag us down this rabbit hole, but there was a recent announcement from Anthropic that they were starting to do early research on like AI rights. So attempting to recognize quote unquote AI sentience, um, because it in an ethical world it will affect the way that we treat AI if we decide that AI is sentient in some way. So there's some early questions about that. I think that is, whether it's science fiction or not, I don't have a strong view right now. But look, I'm glad that I think Anthropic does a lot of things that I'm glad that they're doing, and that is, I think one thing that is, whether it's marketing or whether they genuinely care about it, I do think it is important to at least think about um, those questions. But another part of what you said is it actually gets straight to sort of another thing that I wanted to talk about, and that is just sort of the state of foundation models, the state of large language models, um, both currently and sort of where they're going in the short term, whether they ever get to AGI or not. One thing that it feels like progress on like the base models is slowing down. And that seems absurd to say because, like there's a brand new model coming out. It feels like every week now. Like there have been entire models that have debuted and then been deprecated uh, just since January. Um, so it seems kind of crazy to say that progress is slowing down, but nevertheless, it does feel that way. It just seems like, especially if you only focus on base model releases, not the reasoning models, it feels like the jump in sort of ability and quality is slowing. Like I can remember being absolutely flabbergasted by the leap from some of the earlier incarnations of the models, whereas now it's like it's sort of harder to suss out, like that they feel better in a way, but it's not so clearly apparent. Does that you get that same sense?
Yeah, I think that's definitely fair. And I think there's a lot of practical components to this. Kind of just to give a sense of like GPT-3 to GPT-4 felt like a huge advancement, right? That was an increase of over 10x in the amount of data and over 10x in the number of model parameters from 175 billion to 1.8 trillion parameters. And that also was extremely expensive to train. I think we kind of talked about this in the context windows episode, but effectively, as you increase the context windows, you're also having to sort of increase the amount that you're spending and time that you're spending on training sort of these ginormous models. And I think something that also really affects how well these models perform is sort of the quality of the data. And these models are meant to be generalizable, right? And so at some point, we're reaching a point that these models have pretty, very, very good generalizable intelligence. And just because they do well on sort of this overall general, on these sort of overall general tests, that doesn't necessarily mean that they will be better for things like law or healthcare or some of these more specific domain specific applications. And so as people kind of think about that, I do think it makes sense that now that sort of this general base level model intelligence has reached at this point of where it's already very, very good, people are starting to focus on things like reasoning models and domain-specific models, and GPT has already made fine-tuning available for multiple years now for sort of these domain-specific applications.
Yeah, yeah. I mean, that makes a lot of sense. There's a lot to sort of dive into there. Um, so there's this concept of the data wall, right? Where like there's only so much human data available. Eventually, theoretically, the companies could get their hands on all of it, train a model, and then that may be the end of progress, at least on the base models. At least that was the description of the data wall problem. Obviously, a lot has happened. There seems to be a lot of techniques for addressing that. Um, I mean, I guess one of my sort of pet issues here around this data wall problem. Um, so there's this paper that came out I think there's a number of papers at this point that came out that said basically um, you can't train LLMs on data produced by LLMs without severely hampering the ability of the LLM. So basically what happens is, because of the way the statistical training works, if you train a new LLM on output from an old LLM, the more you do that, um, it basically shrinks the edges. So like you lose a lot of the sort of uniqueness at the ends of the curve. Um, that paper has always been really fascinating to me. One reason being that it sort of suggests like a sliver of value and capability to human reasoning that may always be there, right? So if you think about the science fiction scenarios where AI becomes AGI and then becomes ASI, like there's this constant question out there of, okay, well, I mean, as you just said, all these fields, right? Like AI is going to be able to contribute in ways that are unimaginable. And you sort of everybody naturally starts wondering, like, okay, well, then what is there for humans to do? For me, this sort of data wall question always suggested that however good it gets, AI will need intelligence of a different kind to train on, or data produced by intelligence of a different kind to train on. That doesn't necessarily mean it would be a good existence, but it has to keep us around for some reason, even if we're, at least we maybe be more akin to dairy farms than to beef farms, but it have to keep us around because it needs real data from us to keep improving itself. That actually does not seem to be as likely a case now. There's a lot of recent research and also just sort of commercial development, DeepSeek, and there was research recently suggesting basically just pure sort of self play can produce better models. So yeah, would love to get your thoughts on that. Like, do you think that the recent avenues suggest that actually human data of any kind may become irrelevant?
Yeah, I guess maybe to kind of outline a few thoughts I have on that. I think you touched on many, many different points. The first is that it's always been known that the quality of data affects the quality of the model that you get. And what I mean by that is, even for the GPT models, a big part before you even start training a model, they're not just sort of dumping the internet in. They're doing a bunch of filtering for high quality content in order to, and what I mean by that is, if you can imagine just sort of dumping uh, like chats of random forums on the internet might not give you the ability
Tweets.
to solve high quality math problems, right? And so sort of the quality of the data that you're using to train these models significantly affects, and has always been known to significantly affect, the quality of the model and how well it will perform on different tasks. And people have tried with different data sets, even before, and I'm happy to talk about DeepSeek at a different time, but DeepSeek released a paper even before sort of the DeepSeek R1, that really famous paper, about how they even prepared the data sets and considered what data sets they were used for training and how that affected sort of the outcomes and how well that model performed, or the predecessor model performed on different tasks, and how they used that. And so the quality of data is definitely super important. I also have seen a lot of papers similar to it. There's where it almost feels like there's sort of these two avenues where people are exploring synthetic data to help with training, and also there's that other line of work where I've also seen similar that shows evidence that if you just sort of dump in sort of model results and use it to train that same model, you see a decrease in performance. And it kind of makes sense to me in some sense that sort of this very simple learning would result in that. I think to kind of give maybe a little bit of an explanation for why we might be losing some of the tail end of the distribution is that for these standard LLM models, you can almost think of them as these really fancy pattern matchers, right? So effectively, how they're trained is that you hide a word and you're trying to predict what word is being hidden. It's a little bit fancier than that, but effectively, it's playing this game that's trying to learn, that uses this task to learn how to behave like a human or speak like a human, or chat like a human. And so since there are these really fancy pattern matchers, the distribution clusters around sort of the most common area of a distribution. And so the outputs will be sort of the most likely word that a human would put in that blank or the next sentence or something like that. And so you lose sort of almost the tail ends of those distributions, which would make sense because the model results are also going to be more distributed towards that most likely result in some way. In terms of though whether or not you can use models to help other models learn, I think there's a bunch of evidence, and probably the most clear one is actually DeepSeek R1, which used O1 to actually help train in a reasoning sense. And sort of what I mean by that is we can go into sort of maybe the high level, the difference between a reasoning model and a non-reasoning model is that reasoning models sort of use this concept called reinforcement learning versus sort of the non-reasoning models are doing this sort of pattern matching game that I kind of discussed on a high level of trying to predict the next word, the next sentence. And reasoning models, the reason why they are so powerful is because you can almost imagine that it is almost like sort of this baby agent out in the wild where it gets rewards in order for performing tasks correctly. And you can actually use a larger model or more powerful model such as R1 used actually OpenAI's O1 to help direct that model to sort of learn correct behavior and behave and reach basically O1, almost O1 level performance in a lot of different tasks with a much smaller model. Sorry, I think that was a lot. I kind of tried to touch upon the different components of what was in the question, but those are.
Yeah, I threw a lot out there, so that makes sense. Yeah, I mean, I would love to go a little bit deeper into this idea of the reasoning versus the non-reasoning models. I mean, one behavior that you see when you are playing with the reasoning models is there's this chain of thought. So, which I gather. So I gather there's a difference between the change of thought that you read in the output versus what's really going on in the model. That would almost have to be the case. The chain of thought, though, is sort of it's producing its own thoughts and then ingesting that back in and using that to improve the ultimate output. Is there more going on there though than just sort of that chain of thought that you can see on the page?
Yeah, well, so the chain of thought that you see on a page for OpenAI's reasoning models is not the full chain of thought. When it's doing that thinking, there's definitely more output there. I also don't know what it is, but the stuff that's kind of outputted is a summarization of that. and kind of the chain of thought and the biggest difference between reasoning models and non-reasoning models is sort of being able to reason through thoughts, and also getting and also that reasoning models are trained using this sort of reinforcement learning paradigm, where you have this sort of agent model, and you're learning in each step whether or not that step is correct and being evaluated. And so that allows you to sort of be able to do more human-like thinking, where you are able to break down problems. And also the training is actually suddenly a lot more efficient, where you have this sort of frozen reward policy. You get rewards for getting the right answer when you're training sort of these math problems, but effectively it can sort of now break down sort of identifying problems as like, oh, this is a quadratic. Now I can break down the quadratic, and then I can figure out roots and things like that.
And do you have a sense? So one thing that I've always wondered, I really haven't found a good answer to this, but so the reasoning models, it's certainly the case that, for example, coding tasks, right? Like they're better at coding. They're sort of better at anything that requires logic and sort of chains of reasoning, which makes sense. I mean, that's the name. But that is because, right, as you say, there's this reinforcement learning process. But in things like a math problem, in things like a coding problem, there's an answer, right? Like you're either right or you're wrong, and then you can train the algorithm by punishing wrong answers or rewarding right answers. So that makes total sense. They will get better at logical tasks through reinforcement learning. What's your sense of how, like, when you do that training, how does that carry over to other tasks? So, for example, the law, right? Like, there's not necessarily a right answer to every legal question. It's often a matter. It's fuzzy. It's a matter of interpretation. But I could see, right? Like I could see it being the case that even training it on these different fields would affect the weights in a way that it would get better at sort of other more fuzzy tasks. Do you have a sense of that?
Yeah. So also part of the reason why these models are so good at coding and math is because a lot of the evaluation sets are actually in sort of coding, math, SAT problems, these logic-based. So it's definitely targeted towards that. And I'm pretty sure GPT trained on like on GitHub, some like repositories, things like that, in
Well,
order to make
there
it.
was a bit of a controversy recently, I think, because some of the like supposed to be closed evaluation sets were leaked to some of the major companies, which
Yeah.
just sort of makes the evaluation sets meaningless, right? They could train directly
Yeah.
on them.
Absolutely. I haven't. I feel like some tasks are definitely much. I can't really speak to law quite as much in terms of what is if there's. I know there's definitely a lot of ambiguity in terms of the court of law and what people decide. But even for creative tasks, there's been a lot of sort of anecdotal evidence that these reasoning models are bad at more creative tasks, such as like creative writing. Or writing memoirs or things like that. So definitely the way that the model is trained and sort of evaluated is more tailored towards sort of these logical reasoning tasks, such as higher level math problems, coding problems, and logic and things like that.
Yeah. So, do you think it may be the case that sort of development's going to have to continue down both sort of lines where, yes, we're getting a lot of progress out of reinforcement learning and the chain of thought reasoning, those sort of things, but we also have to keep pushing forward on just the base models because that's very important for sort of base language production to the extent that feeds into chain of thought, that sort of thing. Or do you think it may become the case where it's like, look, the models are as good as we need them on the base models, and now we can just totally focus on the reasoning side, reinforcement learning side?
I'm definitely not the one making those decisions, but I think that the evidence is pointing more towards the latter. But I would also say I think development is actually sort of touching on a topic that you were talking about earlier, actually extending beyond language. And so I feel that like in industry, robotics almost feels like the next largest frontier, where language and images and utilizing tools and agents, that's sort of like the next almost, and sort of this multimodal learning almost feels like is sort of where people are starting to push the development to sort of these foundational models. And kind of on the opposite side of that, I also feel like for more tailored domains such as medicine and where I have a lot of friends working in the field of computer vision, especially for medical purposes, there's been a lot of research and development in terms of developing synthetic data and creating more generalizable models for things like X-rays and MRIs and things like that. And those models are tailored specifically for that domain. And so I think we're seeing more evidence of more both sort of that domain specific shift, where people are sort of building off of these base models and these base learning foundation model techniques in order to create more domain specific models. In sort of maybe I think there will be in both legal contexts and also in medicine as two examples of domain specificity. And I think there's also sort of this multimodal push as well. So maybe if we have exhausted sort of all these language resources in terms of quality data, how can we start learning with these different, almost like different senses? We're starting to incorporate more vision level models. Voice agents is a huge thing to start touching on voice data and other components as well.
Awesome. Yeah. Well, there's so many threads there that we could keep pulling on, but maybe we'll pick those up again later. So just to wrap up, let me tell everybody about Marveri. Marveri is an AI-powered platform that helps corporate lawyers quickly make sense of large groups of documents. Super useful for M&A, for onboarding new clients, really any legal task that requires quickly digging into a bunch of documents. You can learn more and sign up for a demo at marveri.com. That's marveri.com. Encourage everyone to go do that. We love showing off our tool. Really appreciate you taking the time, Emily. Thanks to everyone who takes the time to listen to these. I think global hit success at this point. Literally dozens of people watching these episodes, which has been amazing. We would love to hear everyone's feedback. Feel free to connect with us on LinkedIn, drop a comment, like, subscribe, all that good stuff. That's been a lot of fun, Emily, as always. Really appreciate it.
Thanks so much, Mike.